Hello everyone, I am Dr. Satish Pangal. Hope you are doing well. In this tutorial, we will learn correlation analysis. Correlation is a statistical measure that indicates the degree and direction of association between two variables. Keep in mind, correlation measures association and not causation. A strong correlation does not necessarily imply that one variable causes change in the other. The association is represented by small r in case of Pearson correlation and rho for Spearman correlation. The correlation value ranges from -1 to +1. On the basis of association, generally we divide correlation into three categories. Positive correlation when both variable increases or decreases. Negative correlation when one variable increases while other decreases, and zero correlation, or you can say no correlation, when no relationship exists between the variables. SPSS provide mainly two basic form of correlation: bivariate correlation and partial correlation. Now, bivariate correlation. Bivariate correlation is a statistical technique used to measure the strength and the direction of relationship between two variables. The term bivariate indicate two variables. Bi mean two, variate mean variable. There are three types of bivariate correlations in SPSS. We will discuss one by one. Pearson correlation, Spearman correlation, and Kendall tau B correlation are the three type of bivariate correlation in SPSS. Pearson correlation. The Pearson product moment correlation measures the strength and the direction of a linear relationship between two continuous variables. Keep in mind, continuous variable should be there. It is the most commonly used correlation coefficient for parametric data type. Before proceeding further, there are certain assumptions, advantages, and limitations of Pearson correlation. Assumptions for Pearson correlations are: the data should be continuous in nature, there should be a linear relationship, and the distribution should be normal. No significant outliers should be there in data, and the observation must be independent. The advantages of Pearson correlations are: it is the most powerful correlation test for continuous data. Keep in mind, if you have continuous data, you must go for Pearson correlation. Interpretation is easy and widely accepted. The limitations of Pearson correlations are: it is sensitive to outlier, require normality, and detect only linear relationship between variables. Let's take an example. Calculate Pearson correlation. We will first add data. To add data, go to the file, select import data, and select the data type. In this example, I am going to calculate whether there is any correlation between rainfall and rice yield. You can see this is a continuous data. So to perform, we will go to analyze, go to the correlation and select bivariate, because we are performing bivariate correlation. Your rainfall and yield would be your variables. Select Pearson, test of significance to tail, and click on OK. The Pearson correlation result indicate that there is highly positive correlation between rainfall and rice yield in this example. Now I will discuss Spearman correlation. Spearman rank correlation measures the strength and direction of a monotonic relationship between two variables using ranks rather than raw value. Keep in mind, Spearman rank correlation use rank instead of their values. It is a non-parametric correlation test and generally used for data which have ranks. The assumptions for Spearman correlations are: the data should be ordinal or continuous in nature. There should be a monotonic relationship between the variables and the observation should be independent. There are certain advantages of Spearman correlations. The advantages are Spearman correlation does not require normality. It works well with ordinal data and is less affected by outlier values. The limitations: Spearman correlation slightly less powerful than Pearson when parametric assumptions are satisfied. It uses ranked data which may reduce precision. So, to perform Spearman correlation, we will again add data. Now, I want to examine whether farming experience affect productivity. To perform this, we will again go to the Analyze, select Correlate and click on Bivariate. Your farming experience would be your variable along with productivity. Select the Spearman correlation and click on OK. The result indicates that there is a negative correlation between farming experience rank and productivity in quintal per hectare for this example. Now we will discuss Kendall tau B correlation. Kendall tau B correlation is a non-parametric measure of association used to evaluate the strength and direction of relationship between two variables measured on an ordinal scale. The question arises, why we use Kendall tau B? Because Spearman correlation perform well with ranked data, but when there are many tied observations, Kendall tau B generally provides more accurate estimate of the association. The advantages of Kendall tau B correlations are it handles tied rank effectively, suitable for small samples and robust non-parametric method. On the other hand, limitations are less intuitive than Pearson, usually produces slightly smaller coefficient value than Spearman for the same data. Keep in mind, while using Kendall tau B correlation, you will get smaller coefficient value in comparison to Spearman when we work on the same data. So to perform, I will again add data. In this example, I am going to evaluate whether there is any correlation between farmer education level and technology adoption. So, to perform, we will again go to Analyze, select Correlate and go to Bivariate. Your education level, technology adoption will be your variables. This time select Kendall tau B correlation and click on OK. The result suggests that the education level of farmer is positively and significantly associated with the technology adoption because the association is significant at 0.01 level of significant at 2 tail. Now we will discuss partial correlation. Partial correlation measures the relationship between two variables while controlling the effect of one or more additional variable. It removes the influence of control variables, allowing the researcher to examine the unique association between the variables of interest. Now the question arises, why we use partial correlation? Sometimes the observed relationship between two variables may be influenced by a third variable. For example, there is a relationship between study hour and examination marks. It may be affected by IQ of a particular student. So, partial correlation control IQ to determine whether study hours are still related to examination marks after removing the influence of IQ. To perform this, I will again add the data. In this example, I want to examine the association between fertilizer use and rice yield by controlling rainfall. So, we will calculate partial correlation in this example. To calculate, go to the analyze, select correlate, and this time select partial. Your variable would be fertilizer use and rice yield, and your controlling factor would be your rainfall. Click on OK. You can see fertilizer use is not significantly associated with rice yield in this example when we control rainfall. In this manner, you can perform correlations according to your data type. Thank you. Have a nice day.